Alright, today we've got an interview style question that reads: prove that n squared times n squared minus 1 times n squared minus 4 is divisible by 360 if n is a positive integer. It's divisible by 360 if n is a positive integer. So what we're saying is that our expression here is a multiple of 360. Now how do we show this? Well, let's just start by playing with the expression. So if you factorize, we'll notice how we've got two brackets of difference of two squares. So if we expand, so factorized, we'll find that we've got 5 consecutive terms, or integers, sorry. So we've got n minus 2, n minus 1, n plus 1, n plus 2. And we know for any 5 consecutive integers we'll have a multiple of course, 1, 2, 3, 4, and 5, no matter what the numbers are. So we can say that our expression here is a multiple of 5 times 4 times 3 times 2 times 1, which is equal to 5 factorial, which is just 120. Right, we've shown that this number, or this expression, is a multiple of 120. However, we need to show that it is divisible by 360. So to get from 120 to 360, we multiply by 3. So we need to show that when we do mod 3 of this expression, call that expression n, mod 3, sorry, it's not right. If we do n mod 3, we get 0. Now, how do we show this? Well, we take our potential values of n, which are, in this case, 0, 1, and 2. And we need to find that they are congruent to 0. So the way we do this is when n equals 0, we've got 0 in the middle as our middle term. We've got minus 1, and we've got minus 2. We've also got 1 and 2. This term here is 0 squared. You can also write these minus terms as 1 and 2, because they are congruent when using mod 3. So now this expression here is congruent to 0 because we just times it by 0. So that means that this, so when n is 0, our congruency expression works. Now when we're on to n equals 1, let's put 1 squared in the middle. We've got n minus 1 to the left, and n minus 2, so we've got minus 1, n plus 1, which is 2, n plus 1 is 2, n plus 2 is 3. Now if we take mod of all these numbers, we've got 2, 0, 1, 2, and 0. Notice here how we've got 2 zeros. That double affirms that when n equals 1, n is congruent to 0. So let's put a tick next to n equals 1. And now when n equals 2, we've got n as 2 squared, and then we've got n plus 1, which is 3, n plus 2 is 5, n minus 1 is 1, n minus 2 is 0. We've got 0, 1, 2 squared, mod 3 is congruent to 1, 3 is congruent to 0, 5 is congruent to 2, we've got 2 zeros. Again, this checks out. So now we've shown that this expression is also divisible by 3 as well as 120. So 3 times 120 is 360. That is this question done.